So is my screen visible to you?
Yes, sir.
Okay. So in the last class, we have discussed about insert a node into a linked list, maintaining the order of that list. Okay. So we have discussed that either list is empty or not, or node may be inserted at the beginning, node may be inserted at the end of a linked list, or node may be inserted at the middle of the linked list. So any question regarding this? Any doubt?
No, sir.
Okay. So today first we discussed a question. Okay. Insert at specific location. Okay. Insert a node at a specific location. Now, suppose we have one linked list, single linked list. Okay. Share value is suppose 10, 20, 30, 40, 50, and 60. So these are the values. So what are the position of each node? Okay. This is the first position, is first node, second node, third node, fourth node, fifth node, and sixth node. Okay. Now we want to insert a node at suppose fifth position. Okay. Suppose you insert a node, so LOC location equals to 5. Okay. We insert a node at fifth position of a given linked list. That means here you want to insert a node. Okay. So here we create another new node. First we have to create one new node. Okay. So this new node suppose P. Okay. So each node has some address. Suppose this node address is suppose 100. Okay. So we create a node P. Now insert a value here in this node P. Suppose insert a value, suppose uh, 49. Okay, insert a value in this node P, and now now we want to insert this node at position 5. So here we want to insert this node. So how to insert? You have to establish two link between this and this, and then this and this node. Okay, so 1 2 3 4, then 5, then now it is 6, and now it is 7. Okay, so insert this new node at location 5. So first we have to search the fifth location node. So what we required? First you can see, first we have to create a node. First one is we have to create a node. Next, insert the data in this node. Okay, insert data. Okay, third one is, okay, find the position. Okay, first you have to find the location. Okay, in which location you want to insert this new node. Then fourth one, we have to establish this link. Okay, we have to establish this link. So how to establish this link? How to establish this link? Here you can see this node and this node we have to connect, and this node and this node we have to connect. Okay, so that means we need to track the this node, okay, and also this node. So this is my LOC. We need to track at LOC position node and before the LOC position node. Then only we can insert this node between 4 and 5. Then we can make it as a fifth node. Okay. So first we have to create a new node. So what are the parameter we have to pass? What are the parameter we have to pass? We know the header, we know the value of the new node, and the location where we want to insert the new node. Okay. So if you want to write the algorithm insert at specific location. What are the parameter we have to pass? First we have to pass the header, the start first node address, the value of the new node, and the location where we want to insert the new node. Now we create a new node P equals to get node. First you have to create a new node, then insert B in the data part of this node P. So we can write data of P equals to B. Okay. Now we have to search the location. So first you have to create the node, insert the data, now find the location. Okay. How to find the location? We declare a variable I equals to 1. Okay, I equals to 1. When we visit any node, then we need to, means I indicate the count. If it is visit this node, this is 1. Then when we traverse this node, this is 2. When we traverse this node, this is 3. When we traverse this node, this is 4. this is 5 and this is 6. So when we visit each node, when we visit the first node, the I value is 1. When we visit the second node, make I value I plus 1, 2. When we visit the third node, I value I plus 1, 2 plus 1, 3. Then when we visit this node, I value I plus 1, 3 plus 1, 4. Okay. So in this way, we need to find that location. Okay. So within while loop, so either we visit until y not equals to null, we visit until y not equals to null and I less than the location. Okay. If y not equals to null, that means when y is null, when after this linked list, here y value is null. Okay. So here we declare a variable y to equals to header. Why we declare this variable y? To visit each node, to traverse. Now, okay. So now here y indicate each node. Okay. So when we stop, when we reached here, when y reached here, y is null. So after this node, then we stop. Or suppose I value is suppose 7. Okay. And LOC equals to 5. Okay. Or I value is 6. LOC is 5. Then we stop. Okay. So here we can write y equals to link of y and increment the value of I by 1. Okay. So when we can say according to this condition, when we can say that location is not present. Suppose we want to insert at location 7. We want to insert a value at location 7. Location 7 is present in this linked list.
No, sir.
So when we can say according to this condition, okay, according to this condition, when we can say that element is that position is not found. When we can say position is not found, so tell me. Y not equals to null and I less than LOC. So when we can say element is not found, suppose here we want
When
to
I greater than LOC.
when I greater than LOC and or another condition. And another condition,
Equal to
when y value is null, you can see here I value is 1, y value 100. So here y not equals to null. Yes, I, what is I value? I value is 1. 1 less than 7. Yes. Enter into the loop. Then y equals to link of y. So now y represent here. Now y not equals to null. Yes. What is the value of y? 200. And what is the value of I? I value is now 2. I value is now 2. Okay. Now again check y not equals to null. Yes. And I less than LOC. LOC value is 7. 2 less than 7. So again enter into the loop and y equals to link of y. So link of y means y again represent this node and I equals to I plus 1. So now I represent this node. So y not equals to null. Yes, y value is 300. And what is I? I value is 3. 3 less than 7. Yes. So both the condition is true. So again enter into the loop. You can see if both the condition is true, then only we can enter into the loop. Now y equals to link of y. So link now, so this is my y and I increment by 1. I equals to I plus 1. So I indicate this position. Now y not equals to null. Yes, y value is 400 and I less than LOC. Yes, 4 less than 7. Then again we need to traverse. So now y indicate this location. Now what is the value of I? I increment by 1. So I indicate this location 5. So what is link of y? What is y value? 500. So here you can say 500 not equals to null and I less than LOC. Yes, 5 less than 7. Then again we traverse. So now this is my y. Now what is the value of I? So this is my I value. Now y not equals to null. Yes, y not equals to null because y value is 600 and I less than LOC. Yes, I 6 less than 7. So again y indicate the next node. So here and I increment by 1. So I value here 7. Okay. So when we can say that, so here you can see I value is 7, LOC also 7. But here we cannot insert a node, cannot insert a new node because we have to insert a new node within this existing linked list. So what is the condition when we can say the position is not found? When y value is
Equal to none.
x is equal to null. Yes. When
And
y
I
value
greater
is
than
null,
LOC.
now here I equals to y, LOC. Here I also 7, LOC also 7. But can we insert this node here? Can we insert this node here? Because we have to insert a node in this existing linked list. We cannot insert this node here because seventh is not a position in this linked list. This linked list contain total 6 nodes. So if this linked list contain total 6 nodes, that means 1 to 6. So how can we insert this node at 7th location? Insert this node at 7th location. So when y value is null, when y point after the means last node. So I point this node, okay, which is next node of the last node. Then we can say the linked list position not found. So here we can write if y equals to null, okay, then we can print
Sir,
yes.
sir, will we write this directly after the line I is equal to I plus 1?
No, then we bracket no, while after the while loop.
Okay, sir.
When this loop terminate, when y value is null and I greater than or equals to LOC. When y value is null and I greater than or equals to LOC, then only this loop terminate. That's why it's a AND condition. If
Yes.
both the condition is true, then only we enter. So either y not equals to y equals to null, then this loop terminate, or I is greater than LOC, then only this loop terminate. Okay.
Okay, sir.
And means if both are true, then only we enter. Otherwise, if any one is false, then loop terminate. So either y not equals to null and I less than LOC. So if anyone is the condition is false, then this loop terminate. So that's why when y value is null, what is the meaning y value is null? That means we reached after the last node. Here we reached. So insertion is not possible because location is not found. Suppose I value is suppose 8. Okay, if you have any confusion, suppose I value is 8. So here you can see I less than LOC. I value now 7, 7 less than 8. This condition satisfied. But y value is null now. Y value is null. So this condition is not satisfied. Then this loop terminate. So when y equals to null, then you can see, you can write position not found and we can exit from the uh, program. Else else means else means if this condition is false. When this condition will be false, suppose here we want to insert a node. 1 minute. Okay. Suppose LOC value is suppose LOC value is 5. We insert a node at fifth location. Now y equals to header. Yes. Y not y equals to header. Yes. Now y not equals to null. Yes. Y value is 100 and I less than LOC. So I indicate this node 1. Yes, because we initialize I equals to 1. So 1 less than 5. Yes, 1 less than 5. And y not equals to null. Yes, y value is 100 not equals to null. Enter into the loop. Now y equals to link of y. So link part of y means this one. So this is my new y. And I increment by 1. So I equals to I plus 1. So what is the I value now? I value is 2. Now again check y not equals to null. Yes, y value is 200. 200 not equals to null. And I less than LOC. Yes, 2 less than 5. Okay, 2 less than 5. We enter into the loop. Now y equals to link of y. So link of y my new y. So this is my new y. Then increment the value of I by 1. Okay. So now I indicate I plus 1, 3. I value is now 3. Okay. Now I value is now 3. Now y value, y not equals to null. Yes, y value is 300 not equals to null. And I less than LOC. What is the I value? 3. 3 less than 5? Yes. Then again enter into the loop. Now link of y. What is link of y? Link of y is this node. This is my new y. And increment the I value by 1. So I value is now 4. Okay. Now check y not equals to null. Yes. Y value is 400 not equals to null. And I less than LOC. Yes. 4 less than 5. Then again enter into this loop and y indicate y equals to link of y. So this is the y. Link part of y means this one. So this is my new y. Okay. And what is the I value? I indicate increment by 1. So I value is 5. Now check. Y not equals to null. Yes. Y value is 500. Y not equals to null. But I less than LOC? No. Here I value 5. LOC value 5. Okay. So here in this case, this condition is false. Okay. This condition is false. This condition is true, but this condition is false because here I and LOC both are same. So we exit from this loop. Okay, we exit from this loop. Here you can see I less than LOC. Yes, I value is 5, LOC value is 5. Both are equal. So that means this condition is false now. But this condition is true. Y not equals to null? Yes, y value is 500, which is not equals to null. Okay. So this condition is true. This condition false. So exit from this loop. Okay. Now we need to. So I indicate this position. Here we want to insert this node. So how to insert this node? We know this node is P. So link of P. What value we insert here? In this link of P. If you want to establish the link, this one, Then we establish this link. Okay. So if you want to establish this link, what is the value of link of P? What is the value of link of P?
500.
500. So here we put 500. Then we can establish this link. Okay. So we can write here link of P equals to Y. Okay. Else we can write link of P equals to Y. Okay. But how do we track the previous node? We can track the next node, because if this is Y, so next node is link of Y. But how do we track this previous node? So that's why we have to declare a variable x. So before change the y, we have to write x equals to y. Before change the value y, so here previous y का लिंक पार्ट में जो है, then that is my new y. So before change the y, the previous y we need to store within another variable x. So x represent the previous node here. Okay. Now you can see here x equals to y. Suppose when this is y, x equals to y, that means this is x. Then link of y. So this is link part of y. That means it's contain the address of this node 500. This is my new y. So this line indicate that we traverse from one node to next node. So before jump from one node to next node, we make the previous y as a new, as a x. Okay. So here x represent this node, y represent this node. Now link of x, here we put the value p. Okay, then we establish this link. So this is x. So link of x, here we put the value p. So here we can write link of x. Here we insert the value p. Okay. Any question? Please go through this algorithm.
Sir,
Yes.
next slide.
Hello.
Sir, can you do the next slide?
Next slide. Okay. Any question? Any doubt? Okay. Now searching. Okay. So suppose we have one given linked list. Okay. So value is suppose 11, 33, 22, 55, and 44. Now we want to search an item. Okay. We want to search an item. That item is present in this given linked list or not. Suppose you want to search that 55 is present in this linked list or not. So if it's any node data part is 55 or not, we want to search. Now tell me how to search.
Sir, we need to traverse.
We need to traverse. Okay. So if we write an algorithm, okay, if we want to write a algorithm of search, okay, and search a single linked list, suppose. Okay. So what are the parameters we have to pass here?
Header,
Okay. So we know the header, the address of the first node, and the item which we want to search. Okay. Now we have to traverse. So for traversal we know we write y equals to header. Okay. Y equals to header, and so while y not equals to null, until y not equals to null, we have to search when until we reached in the after the last node. Okay. So here, so when y not equals to null, we search. Now here we have to write if, so we visit each node and check. So first node, suppose this is y. Now check data of y equals to item or not. Okay. So item equals to data of y, data part of y. Okay. Item equals to data part of y. So what is the y value? Data of y 11. 11 equals to item. 11 equals to 55. No. So again we traverse. If item equals to data of y, then we print the element is found. Okay. And you can print the position. Suppose this is the first position, this is second, third, fourth, fifth. In which position element is found, you can print. So that's why we declare a variable count. To initialize count equals to 1. Okay, count indicate the position. So print element is found. Okay, and print the count value. and we need not to search again. Suppose you want to search 33 or 11. Suppose your item value equals to 11. So data of y equals to 11, yes. So need not to search the rest of the list. So that's why you need to exit. So here we declare a flag equals to 0. If the item is present, then make flag value equals to 1, okay, and break, exit from the current loop, okay. Otherwise, if this item equals to data of y, this condition is not true, so never enter into this block. Then again we increment the count value. We increment the count value by 1.
So what is flag?
What is
Flag.
flag? Okay, I will discuss. Okay, and again y equals to link of y. Okay, if so, when we can say that element is not present, element not found, when we can say when never entered this if block, okay, this condition never true, and we also reached at the y, when y value is null, and means when we reached after the last node and never enter into this if block, item equals to data of y, then only we can say element is not found. Okay, when we can say element is not found, when y not equals to null, so this condition is false. That means y point this condition, this location null, and item equals to data of y, this condition never true, so never enter into this if block. Okay, then only we can say the element is not found. Okay, element is not found. So if never enter into this block, so f value previously you can see f value previously is 0. If we enter into this if block, then only f value is 1. Otherwise f value remains same 0. Okay, so when we exit from this loop, if f value remains 0, f value equals to 0, then we can print element is not found. Okay, we can print element is not found. So here f equals to 0, we'll declare a variable f equals to 0. Now y not equals to null. Initially y value is not equals to null, yes, because it has own address 100, 200, 300 and all. So if item equals to data of y, so what is the item? Item is 55. What is data of y? 11. Okay, 11 equals to 55? No. So then we increment the value of count plus 1 and link of y is my new y. Okay, so now y indicate this node and count indicate this. Now y not equals to null? Yes, y value is 200. Enter into the loop. What is item? 55. Data of y? 33. 55 equals to 33? No. So never enter into this if block. So again we increment the count by 1. So count indicate this location and y indicate again this location. Now y not equals to null. Yes, y value is 300, not equals to null. Then enter into this while loop. Item 55. Data of y. What is data of y? 300. 22. So 22 equals to item? No. So again increment the count by 1 and y indicate this location. Okay. So suppose this node address is 400. So y not equals to null? Yes, y value is 400. So enter into this loop. What is item? Item is 55. And data of y? So data of y also 55. So now enter into this if block. Now element is found and print the count. What is count value? 4. So at fourth location the element is found. And initially is f equals to 0. Now change the value of f by 1. So f equals to 1 and break. So exit from this current loop. So we exit from this loop. Now, f value equals to 0. No, f value is not 0. Okay. So why we have to check that f value is 0? If never enter this if block and y value is null, then also this loop terminate. Okay. And if f value is 0 and never into this if block, so f value remains 0. F value remains 0. Then we can say element is not found. So that's why we use this flag. To check after exit from this loop, what is the f value? If exit this loop because of only this reason, okay, then f value is 0. If we enter into this if block, then f value is 1. If f value is 1, that means element is found and it's print the location. If f value is 0, then element is not found. Is it clear to you?
Yes, sir.
Okay. So this is similar means like linear search or search in an array, similar thing. Okay. So again we meet physically. This is the last class in online mode. 101, 119,
Sir, 101 present, sir.
119,
Connection went off.